Hello, it's Dr. Mike here. This is for my CIS-2640 Network Security or / Security Plus class. At the time of this recording, this is topic 13, usually week 13. It's on vulnerability assessments and data security. Again, at the time of this recording, this is a textbook chapter 13 under the same name. Again, as usual, I will probably just cherry pick a few slides I think are important topics to talk about, and we'll look at the summary, and I'll show you some other assets you can use in this in vulnerability assessments. So anyways, vulnerability assessments and data security. Vulnerability assessment from the textbook itself, I think a really good identifier here is this aspects list. And probably the hardest and the first thing you do is asset identification. So we will talk about that, and of course in the process of seeing what you have, what threats are there for it, appraise the vulnerabilities, look at the risk, and then look at mitigation strategies. So again, we're going to look at risks from all different areas, but let's talk about assets. So we think assets, first thing comes to mind is probably hardware or data, hopefully. And that's probably the utmost one, is probably data security should be probably the utmost, top of the list of the utmost security. But you got to think about people, their physical assets also, hardware, software. So identification is the process of inventorying these items. So really we could almost start this process, and I'm going to build this little spreadsheet here, which I would suggest. Actually, it's not a bad idea. It could use a database, and hopefully there's assets that are listed somewhere. So if you have an IT department, an inventory of all laptops, desktops, servers, things like that should exist. But it might be possible you might need to actually do a physical walk around and find these good an Nmap scan, and see what's open where, and you find an IP address for a server that you forgot you had. And this is a good phase of asset identification to do this, because as we talked about before in previous topics, that missed server that's unpatched, unmanaged, becomes the weak point. And I believe that happened in the Sony, one of the Sony attacks was from an unmanaged server. And when it comes to the corporate, large companies, everyone's got their scope of responsibility, right? They have their servers, and there's one sitting next to their servers. They don't know what it is, they don't know whose it is. They don't have time to. They don't look at it. They're not going to take time to do any work outside the scope of their own asset pool. And it's not because they're being selfish or being in a lack of security. They only have so much time and resources for security, so they're going to use it against what they are responsible for. So again, there could be a server sitting over here someone forgot about. No one's going to claim it. No one's going to look at it. So as a security analyst, it could be a good point to do that scan, do a physical walkthrough, and find these assets. So start with all the items you have. We'll build our assets here. We might have, of course, the name itself, information about it. Is it a server, desktop? What is it? Like a category. And then maybe information about like the OS, any patch levels. You can see you can build out information here, and not just for software, but hardware. We know what version of the hardware is it. It's very important too, because hardware can be out of date. Hardware can have actually have firmware vulnerabilities in them. So after inventory has been taken, this is a huge step. And it's a step that should not be done once. It should be done at least every so often. It's going to depend upon your vulnerability assessment, risk assessment sort of guidelines set forth, usually by a CISO, or maybe by other factors. Could be PCI, HIPAA compliance. So you should be doing this all the time and keeping an ongoing list of your assets. So another thing too is, what's it worth in a way? The name, money, what's the value of this asset? And then we can look at hardware having a category, right? we have a hardware category. We have a database here. We'll call that software. There's no OS, but let's say there's a patch level. We'll say OS version. So maybe we're looking at, this is a SQL Server at 7.1. I'm totally making it up right now. I have no idea what SQL Server is at right now. So this database is running out of this, but the data itself, what is the cost of that data? What's the money? Maybe this is hardware here. This is a server. It's a web server 1, WB1, it's a great name. It's Linux. It's running Apache version so-and-so. Patch level, 3.x, of the, let's say, we'll look at an old kernel, but Apache level 2.x, whatever. And is there a value to this? And that's tough to, it's tough to put a value on data. Hardware you can put a value on. We can put value in our hardware. We can put value on some software too, installation software. But data can be hard to put against this. So you might assign a numerical value somewhere inside here too. And this could be a value level. So let's say a desktop have a value level of, 2. Maybe it's a hard, it's a very important desktop, but it's a workstation. But let's say the database value 5, right? So again, there's just guidelines here. But you can start to see what you're doing. You're starting to collect information about what you have, and you're starting to assign a value to it, and get information about that asset. Again, hardware information and so on. So we'll go on here and we take this spreadsheet, and you're going to go ahead and look at threat evaluations. So again, when you're done, you have this spreadsheet of everything you have, all your items, all your assets. In there, you might have some sort of value indicator, a metric for value. Again, maybe it's 1 through 5, right? 1 through 10, whatever. Just pick a number and stick with it. Be consistent. And you assign that value, and usually it's agreed upon, and not just by yourself, but probably by, could be a committee. At least a small group of people should at least look it over and sort of verify that value. So 5 being the utmost, 2, here's another 5, here's a 1, and then a 1, and so on. So next we have threats. So threat modeling, attack trees, these are great ways to look at this. So first off, sort this list. So everything with a value of 5 comes up first. Because what's going to happen is you're going to have a lot of assets, and you might need to break up this asset list by division. If there's a security group for each division, they should need to break it up and do their own. You can't expect one person to have all the assets, let's say for like a college or for a huge institution or a huge company. So division work is going to be important. Consistency between each group, always using the same values as best as possible. Just giving a 1 through 5 as a person can be tough. I can give something a 4, you might give it a 5. So there's some human factors here. But don't get hung up on that. It's better to have something assigned than totally missed. So we assign it, we sort it, and we take our top most valuable things and we look at threats against them. Now you'll see in the chapter talks about pen testing. You could assign a pen test to some of these. It could be a checkbox item. Has a pen test been assigned? Yes, it has. You wait for that to come back. So what threats do we have against this? Well, let's say this is 5. This is our database. Well, it's our database of customer data. So we have, of course, there's fire, flood. There's physical things, of course. So backups. And right away, I'm already jumped to mitigation, but right away you should go, well, we should have backups for that, both offsite and on-site. You can see how this chain's going here. But also we have possible data exfiltration, right? So data breach. And so how can we mitigate against that? So how can a data breach happen? That's where attack tree comes in. Well, this database is exposed via, we have a web server, and then we have an app server layer, and then we have our database. Our customer logs in with certain credentials. They can update or access, they can view, update their data. Their credentials are back at the application layer, and our database, of course, is being held in a database server. It is encrypted, but if someone was to somehow, maybe we find through our attack tree, potential attack of right here, these credentials. If someone get these users' credentials, we find they can be modified to see a different user. So a horizontal access, right? Horizontal escalation, or user account horizontal movement between user accounts. So we find that the session ID is broken between, and the user ID number, there's no relationship there. So you can log in with as a valid user and change this and become user user number 12345. User 123. You can change the last digit 124, and now you can also view and change that data. So, can that happen? You're not sure yet, but that's a possible attack tree. And this goes back to what we seen before: OWASP, authentication, authorization, security configuration, of course, data breaching, right? Can someone hit the web layer and do a SQL injection and it get to our database? Can someone do a cross-site script? So you can see where previous topics we talked about come into play. And this is where a pen test might come in. It might come in and help sort of figure out what really is here. And we'll see it's also a vulnerability scan. So I say pen test, it could be a vulnerability scan that can be ran internally. There's a lot of tools you can use for this. Nmap itself actually has a vulnerability scanner built into it, believe it or not. So it's got a really good one. But also you have Nessus. There's the OpenVAS, Greenbone Security Assistant, things like this. You can run against these assets. And the thing is, again, this value here is going to tell me where I need to run that first. So, and the real high value stuff, I might want to set up attack trees. Again, look at the category of threats. Sabotage, human error, that's a good one. So not everything is malicious in nature. Fire, flood, things like that. So power cutoff, technical obsolescence. This is a good one right here. What happens if our database goes out of support? Well, we do a plan for that. So things like that. So again, vulnerability appraisal. We find our current weaknesses, and so from this, we do find out we have vulnerabilities 1, 2, and 3 against this asset. So let me clean my board a little bit. So we go through this process the best we can, and it doesn't all happen once. It should happen, again, quarterly, or happen at a set amount of time, maybe once a year. So a quarterly vulnerability scan, or a monthly vulnerability scan with a quarterly pen test. Again, we do this for the high-level stuff here. So this is asset number 5, their database. Maybe we have some servers here too that are in this. They go through vulnerability scans, and they go through attack trees, pen testing. And from those, we find out we have specific vulnerabilities against these. At least let's take this database. We'll pick that out. So we have our vulnerabilities. Now we can go and organize our vulnerabilities themselves. Look at the current vulnerabilities and catalog them, and say, okay, well, what's the actual risk this actually happens? Is there a risk factor? So like, is it a 10? It's like if it what's the risk of it happening? 10 very easily can happen. 1, somebody actually need to break in and have physical access for that vulnerability to occur. So it's along the lines, something called the CVSS, and not the pharmacy chain. CVSS scoring, Sergel uses with this. I won't go into it here. I think the chapter might talk about it. If not, definitely look at CVSS. It has a breakout of how to score the likelihood. So like does the attacker need to have any technical knowledge? Do they need to have an existing login account, for example? So let's take that example where we find a user can log in with their proper credentials, and they change something in the cookie or in during the session is broken. Session management is not working correctly, and they can become user 1, 2, 3, 4, 5 from user 1, 2, 3, 4. Change that last character. So they need to have valid user account, which is usually provided maybe from someone, maybe they're a customer. It's not just given out, you don't just register online. So again, that lowers the attack vector, and it lowers the chance of it happening. 10, let's say 10 being, well, 10, they just be able to see the server online. They can scan it and they can hit it with a certain type of attack. So a 10 is, easy to kick off. Where 1 is maybe they need to be physically in front of the machine and plug in a USB key, and so we have physical security in place for that. So then, what is the risk of it happening? And what happens if it goes off? So what happens if we can actually do it? And that's our impact. There we go. And our impact analysis. What's our impact? So I mean, someone in front of it could be, well, that's a 9. Someone can get here. It's supposed to be a 9. Someone can get in front of this machine with a key and plug it in, and they might be able to do something else. This vulnerability has a 9, which could take the server down. So we have a service interruption, which hits our availability. Where this one may be, well, it's a 5. They might be able to alter a user account. Maybe somewhere there's a 9. It's easy to do. Maybe they need an existing account, but also the impact is 9. Where not only can they, let's go back to that attack example. Not only can they see other users' accounts, they can probably just build a simple script and loop through and pull off and hensely breach personal information, because that user account screen that they can see has not just their login information, maybe not their email address and their current information as a customer. Maybe it has name, address, phone number. It has PII, personal identifiable information. What is a tongue twister? So again, back to the data, right? What can this impact of this be? So with this information now, again, give it impact, small impact, significant. I would put a number there, if at all possible. Here we go. You can sort this list again. Let's sort it again. So sort by these columns, and we come up with what? Maybe this vulnerability number 2 is the highest thing. And then this first vulnerability is first, and then this is the third one we should approach. Now we have a way to approach it. So 2, 1, and 3. So now we know what we need to tackle first against what would be our most valuable asset that's worth the most value if something is impacted by it. And now we can look at mitigation strategies. How do we mitigate for this? And we'll come to that in a second. So again, these steps here of identifying our assets, assigning some sort of value to them, as well as collecting information about them, helps us sort and figure out how we can look for vulnerabilities to those, vulnerability assessments, pen testing, just looking at, patch, out of patch, things like that. Sometimes the assessment is pretty easy. Sometimes it could be as hard as having to hire a pen testing company to do it. But in any case, at least you know where to start. And again, this goes back to money. This stuff costs money, whether time, effort, or even contract money with an external company. You want to make sure that when you're spending the company's or institution's money, it's in the best place. So you can show you're placing the best value for the utmost protection at the most valuable assets. So here we go. So we can identify the assets, vulnerability appraisal, risk assessment, mitigation. What do we do now? So this slide's sort of out of order, but it's a good slide. I don't know why it should be earlier in the slide deck. How can we do these vulnerability assessments? Port scanners, analyzers, grabbing tools, other tools. So let's move on here. Banner grabbing. I'll move past this. So here's some other tools here. Vulnerability scanning is probably the one thing though. So again, Nessus, OpenVAS, Greenbone Assistant, which you've probably done already or will do in a NetLab for this course. Automation is great. You want to be able to automate and run and then send out a readable report, especially if you can keep historical data to show sort of your position. How are we looking in a historical sense? Have we improved? Are we getting worse? So again, personal data. Probably, data itself should be evaluated not just as we have data, what is that database, and does any laws happen against it? So I think I got way ahead of this slide deck, didn't I? So security posture is a big thing here. Configuration information, hardening, and so on. So again, how can we mitigate this? Let's just talk about mitigation strategies and we'll come back. So we got a few things we can do. One, of course, is we can see, is there a direct mitigation we can do? Can we patch this? Is there a patch we can do? That's a horrible way to see patch. I'm trying to write on this. Can we patch it? Or is there something we can put in front of it? Some sort of mitigation. So in other words, we find, well, this is a possible SQL injection. So we can do, we need to go back and look at our code security. And this is probably somewhere in the slide deck. It says we need we have a certain field that's in SQL injectable that came from a pen test. So now we know where to actually fix that one field. We can put that into our change management system and we can get it out as a priority 1. So make sure it gets tested, evaluated, and then pushed out. Hardening, is there something we can harden? So maybe we use a server. We find we have a bunch of servers. We have 2 or 3 servers here that are out of patch and they have open ports. So we need some hardening things in places. So this could also expose not just something that like a technical aspect, like can we put a patch in place? Can we change some code? Can we do any patch our middleware? A lot of it is, can we just harden our systems where we don't have an actual procedure for going through and verifying, hardening, and creating an image, a hardened image that we can use and audit and verify everything against it. This is great for cloud. You build sort of an image and you sort of copy the image out. And you need a server, you copy that image and you go and configure it with the specifics like server name, maybe IP address, things like that. But we know the patching, services, ports, things like that are all been hardened, which we talked about in a previous chapter or so. So again, mitigation strategy, I'm sure it's probably in the slide deck here. Can we patch it? What's the cost of it? That's going to be very important. If it's high value, you can show, you need to prove why you need to spend money. And this will come into play when it comes to older assets, things that are sort of no longer in new release, new production. It's sort of in maintenance mode. And when an app goes into maintenance mode, it really doesn't get as much money because there's no money for anything new for it. You just want to keep it alive for current customers. Having this, we need to spend money for it is a very hard push. And I've had to deal with showing here's the actual vulnerability, here's the risk of what can come out of it. To have some sort of leverage money to put, again, people and time against it. So it's good and important to have this information. Another one is just risk acceptance. We just accept it. In other words, maybe down here, this third one. Well, it's going to cost some money to get this fixed. And this system's going to be end of life in another year. And it's a low risk of happening. And it's maybe the item itself falls in a low value item. Maybe it's a 3. So based on that, you could say, well, we accept the risk. Now, when you say we, that should be someone higher up. The executive level should someone just sign something saying, I've been told that these assets have this risk, and it's a very low chance of it actually happening, and it will cost, we estimate this much money to fix, and we're not going to do it. So we need to have, I accept the risk as CISO, CEO, somebody with that executive level should sign that. It should be up to a manager, really should be higher up, so get the final nod on that. So, but risk acceptance is something you can put out there. Also, another one here is risk transference. So let me clear my board a little bit and talk about that. So what does that mean? Risk transference. So we transfer risk by doing this. So let's say we find we have this risk level here. Number 2, we say right now we're doing, because we need to be PCI compliant, again, we have the compliance in place. PCI is in charge here, and this second one deals with a payment system. So this risk is dealing with, looking back to an asset that is our payment database. So the reason when we first started this company, we made our own payment database. And now PCI compliance, we're not up to PCI compliance. So, and there's a lot of money to go back and make this asset PCI compliant. And it is high risk. It's got vulnerability number, it's a 9.9 vulnerability. Someone from external can hit it, they can then get out credit card information. Definitely don't want that. So vulnerability number 2 against this asset, which is a number 5. These are red flags. This is the alarms are going off here. So what is risk transference? Well, let's say, you know what, we're going to retire this and we're going to move to use PayPal or use Apple Pay, right? And this is why you see companies, maybe you've gone on and bought some merch, use that word, you bought something from a company, and maybe some cool laptop sticker or something like that. And when you go to buy it, they say use Apple Pay, Android Pay, they use or PayPal. PayPal's a great example. And you think, well, you think, well, first it's convenient, right? I have a PayPal account, so convenience is utmost. But second, really, you don't see this is security. PayPal itself, Apple Pay, and so on, usually have already have high levels of PCI compliance put in them. They can offer information showing they're compliant. And all you store is like the last 4 digits of the credit card number, or in this case, the number, the Apple ID number, and of course the account number. And then that's it. So we have the account number, the last four digits of the credit card number, and the transaction number. And that goes back to our sales database, which maybe has like, a person bought a bag of laptop stickers for 20 bucks. Here's the last 4 digits of the credit card or PayPal ID or something. Here's their account number as a customer. And that's it. So if this number was breached, there's nothing here besides the history of this account number buying this. There's no credit card breach. So of course you have to pay money, right? You would pay PayPal, or it would cost money to first off to retire this asset, and of course safely archive this information or find a way to scrub it. So you just can't delete it. We'll come back in a second here. It comes to data handling. But you can see where we transfer that risk now of credit card exposure to PayPal, Apple Pay, Android Pay. So that's risk transference. So there's mitigation, acceptance, and transference. So data label handling. It's important to understand your data. Again, is it confidential, private? You probably should have some sort of administrative controls in place, some sort of security policies that say all databases must have a label somewhere. It could be in a description. It could be an asset tag number. It could be something. I know cloud services like Amazon, you can put certain tags on things, and if it's confidential, if it's PII, if it's public health information. Then this data should be evaluated, the database. What records does it hold? If it holds these certain records, it gets a certain tag. Maybe it has PII and PHI, and it's confidential, or it's proprietary, but and also has PII. So you can say multiple tags here. And there's ways to hang these labels on things, but it's important to have this because if we have those tags, when we do this risk assessment, the tag information can be here, and we can automatically know the risk of that data being exposed. Excuse me. So we come back to my thing about, let's say we do risk transference, and we want to retire this payment system, and we're going to move our payments infrastructure to use PayPal. Well, now we have a database, though. We don't want to delete it. We have a database of old payment data, which has credit card numbers, user information. We got to be able to handle this. How do we destroy it? How do we archive it? First thing coming to mind would be encryption. Definitely encrypt this database. But also, if we get rid of this server, maybe we sell it. We don't need it. We just sell it. We just put it on the open market. It's not unheard of to sell old assets. Or even if we move this asset out to a different group. So, and this happens a lot. And yeah, maybe the test team got some old production servers that were running sensitive data and they don't wipe it properly, well, the server somehow gets breached or it just mishandled, there could be information on this server that could be of importance. So proper sanitizing, destroying, shredding, data wiping. So before the server is given out, let's say the payment group given to to the test team to use for testing, they either got brand new servers or they did the PayPal move. The server should be wiped securely. Yeah, I think it's 7 times with zeros. Degaussing, removing the actual disks, maybe having the testing buy their own disks. That way they do get some hardware, but they got to buy some hard drives. I've seen it happen before. It's easier to just do that and destroy the disks. And of course, physical paper. We talked about before, dumpster diving. When we think of data, we always think of electronic, but don't forget, we should have rules in place for how we deal with printed data. So that's pretty important there, and that keeps us up to par with the chapter. Let's look at the chapter here itself: vulnerability scanning, pen testing, data privacy. I think I covered most of the good stuff here. As usual, look at the chapter. It has some specifics on pen testing and some of the tools for vulnerability scanning. I didn't talk about here. I just want to talk about the overall aspects. And before too, again, you're thrust into a position, you're an InfoSec engineer, and you're like, hey, we need you to do a vulnerability assessment for this group, this team, let's say. Where do you start? You start with a blank page. You don't have to, again, you don't have to. NIST. You got some great stuff here on NIST. Guide for Conducting Risk Assessments. Look at this. Again, you're going to come across, even if you're brand new, the brand spanking new security engineer, they're going to go, wow, you went to NIST. You say, yeah, I went to NIST. And I downloaded the NIST 800-30 Rev 1. And in here, I pulled out what I think is important for our risk assessment. So again, you don't have to use this exactly, but here we go, the process. This is fantastic right here. This is a great asset. You can probably go through this. Some of the stuff's high level. You can actually follow this step by step. And you can create a spreadsheet. Did I do step 1? What did I find? I have any notes? Step 2. So you can create a project plan, whatever. Use some sort of planning utility. Some project planning is very important. I know I myself was a project manager for a short stint. I'm not a big project manager. I'm not a fan of being one, but be able to manage your projects is very important. So manage what you did. Did you complete it? Are you on the next step? You need to go back and redo a step. And this is a fantastic asset here, which you can use to sort of get ready and do a risk assessment. So again, that's a NIST 800-30 Rev 1. And also, there's further training. SANS has training. You literally can go to MGT 415. I'm not sure what the prereqs are, but there's classes on how to do risk assessments. So I know we think cybersecurity, you think it's, it's all, I'm going to learn how to crack stuff, how to scan stuff, and it is very important to be able to do that, understand how those tools and how those work, but also understand the administrative and the management side of handling risk. That's what this chapter sort of goes into. And if you find out that maybe you have a chance to take further training, I definitely suggest it. So anyways, that wraps up the chapter. I hope this was helpful. Thank you.